Yes, we left off in the last video by considering or asking the question, what is actually the variance of x, y? Is it the variance of x plus the variance of y, or not? And exactly this question we want to answer today in this video. And we will see that it has something to do with the covariance and the independence of the two random variables x and y. Okay. We will first introduce the covariance of two random variables. You remember we have already introduced the covariance 2001, or the covariance, and of course the correlation coefficient for samples. And what we are doing now is something very, very analogous, only that we are no longer taking a mean, but an expected value. And we see that here in the following formulas. So where are we? We have two random variables, x and y, so EOs. It is again the case that the covariance contains two different parameters, in this case now random variables and no data. Previously it was data. And what we do is we consider xx and yi, and we multiply them together and take the expected value of that. And that is exactly the covariance of x sos EOS. And that was exactly how it was. If you think again about the covariance of x and y in the data, it was more or less the case that you take the sum of psi x, y. So you see the relationship between x and the expected value, and that this sum divided by n1 is also something similar to an expected value. This means that this is the expected value you see there. And that is exactly the covariance, which also represents a relationship between two distributions. And that helps us enormously now. Namely, we want to understand how covariance is related to the variance of x and y and their sum. And now we will look at the following statement, which we will not prove, but which illustrates the relationship. So we have again two random variables, x and y, and the following holds, and this is actually already the solution, namely that the variance of x, y, is the variance of x plus the variance of y. And then there is an additional factor that comes in here, which is twice the covariance of x and y. That means the covariance is, so to speak, the error we make when we consider how much it deviates from the variance of x plus the variance of y. This is, so to speak, one formula that we have. Then we also have a shift law for covariance. This helps you calculate the covariance. And how does that work? You can also calculate the covariance by taking E of x times y. E of x times E looks quite similar to the shift formula for variance. And here you can already see something very, very crucial, namely, now let's look at the case where x and y are independent random variables. For that, we already know the formula for E of x times y. Well, then it's E of y times E of y. Yes. And that's simply x, y. And then you see that this term here becomes 0. And that is exactly the third statement, that if x and y are independent, then the covariance is 0. Well, and if the covariance is 0, then we can take another look at Formula 1 and see that indeed the variance of xy equals the variance of x plus the variance of y. This means that in the situation where x and y are independent random variables, this nice formula holds that the variance of xy is simply formed from the sum of the variance of x and the variance of y. And now we can look at the experiment, which is the roll of 10 dice. You remember, in the previous video we looked at a die and multiplied it by a factor of 10, and we saw that it is simply 100 times the variance of a die roll. And now we want to consider what happens when we have 10 dice. And we can now interpret this as having a random variable that is simply the sum of 10 random variables, where, for example, x is the sum of the two faces of the dice. And the nice thing is that the xi and xj are each independent. Yes, we have already considered that the rolls of two different dice are independent random variables. And with that, we know that the variance of x, and so on is 1,000. So the variance of x plus the variance of x plus the variance of all the variances. And that is simply 10 times the variance of, because the variance of x and x is the same, it is simply 10 times the variance of x, or 10 times the variance of 2001 of a die from a single die roll. And here you can see the very clear difference. The variance is much smaller than the variance when I calculate the sum of the dice 10 times, because there it was a factor of 100, and here it is only a factor of 10. This is, so to speak, a much smaller variance than that of the example of 10 times the sum of the dice from the first. Well, that was a brief overview of what the covariance of random variables is and how it relates to the formula for the variance of x. Exactly, that means the covariance indicates how far one is from the independence of random variables. This can also be understood because we have also seen that when it is 0, they are independent. If it is not 0, then it is exactly the error we make in the formula for variance xyi compared to variance x plus variance y. Well, then we will soon look at a special topic, namely Chebyshev's inequality. And then we will look at the example with the stock price. Take care.